Following is a multimedia presentation that's a supplement to the Sustainable Country Living book. This topic, Alternative Energy Choices, completes the topic of different kinds of alternative energy in previous chapters. This dovetails with Chapter 12, Alternative Energy Choices. We have looked at, in previous sections, different kinds of alternative electrical power generating systems: solar, wind, microhydro, geothermal, and pedal power. The goal of this presentation is for you to consider which of these options might fit your particular needs the best. And this, of course, depends on the property location where you are going to install this alternative energy. For instance, you can see this picture here of a homestead on the edge of a river, and there's trees around and mountains in the background. So in this case, there probably would not be the option to do wind because of the trees and the closeness of the vegetation to the building. But there is a river, and that's a possibility of how to use some form of microhydro. And solar would work with almost any environment. So a person needs to look at the property that they either already have or are looking to purchase and say, what natural resources do I have available? And that would dictate which of the alternative energy options might work for that property. So we're going to start at the bottom of the list. And we already looked at pedal power in a previous session. And it was concluded that pedal power is not practical in terms of using your muscles of your body to be able to produce enough electricity for your household needs. In the presentation about pedal power, we analyzed all kinds of different methods, including hand cranks and pedal power, like on a bike, to make electricity. And we found out that it is not practical to consider pedal power as a viable option for generating enough electricity to operate a house.
Oh hey, did you know pedal power can generate about 60 watts of electricity per hour? That's enough energy to brew 3 cups of coffee. Not into coffee? You'd have to pedal for 24 minutes to blend your morning smoothie. Or 2 hours to charge your iPhone. Generating electricity using pedal power, it's exhausting.
And that, Bookie McReader Pants, is why you can't power your house with a bicycle.
So you can see pedal power isn't practical in terms of generating enough electricity for a whole household. You would have to pedal all day long to produce enough power for one light bulb. And in that case, it's probably just a 50-watt light bulb, not even a 100-watt light bulb. So it's obvious that a house cannot be powered by pedal power. On the other hand, there is the validity of considering less expensive hand crank devices that can help in an emergency to have a flashlight, a radio. Some devices have solar, and it's important to be able to have a method in an emergency where maybe the batteries would have gone dead on your device, that by having a hand crank emergency unit, you can not only have a flashlight and a radio and maybe even supplement with solar, but also be able to charge up your mobile devices like your cell phone. So if your cell phone battery is dead and you need to call for emergency help, having a hand crank device that can help charge it up would be very useful. So in general, pedal power is not a practical alternative energy for doing your house, but it does have merit when it comes to a small emergency power generating by hand. The next alternative energy option we want to look at is geothermal. And we know from our previous discussions that geothermal is the concept of taking the heat of the earth 10 feet or lower in the ground, and using it to supplement a person's electric furnace in their home. This allows for air conditioning as well as heat. The problem is, on a homestead level, it's very, very unlikely that you could generate electricity with this method. Yes, there are some large-scale power companies that do generate geothermal electricity, but it's going maybe 2 miles deep in the ground, which is impractical for a homeowner to be able to do. So here's some video clips about reminding us how geothermal works.
And once you get down to about 6 to 10 feet below the surface, the Earth becomes a consistent 50 degrees Fahrenheit or 10 degrees Celsius. That's critical for the efficiency of the heat pump system because no matter what time of year it is, we can always count on having that 50 degrees Fahrenheit to pull heat from in the winter or move heat into during the summer. The exterior air temperature is less of a concern, but by using a compressor, they can boost that heat from 50 degrees Fahrenheit up to comfortable temperatures for your home. The heart of a geothermal heat pump is made up of a heat exchanger, a compressor, and a control system that regulates the process. The fluid that's used can range from groundwater to a water mixed with antifreeze or another suitable refrigerant that circulates throughout the ground loops. But during the winter, the temperature underground is higher than the surface air. So the cool liquid traveling from the house down inside the loops absorbs heat from underground, bringing it back up into the house. And the heat pump compresses the liquid, increasing the liquid's temperature, which warms the air. And the warmed air is circulated around the house and exchanged with the cooler air. The cooled liquid from this process is pumped back into the ground to continue the cycle, forming a closed loop. In the summertime, this process is reversed. The lower temperature refrigerant absorbs heat from the house, which now has a higher temperature than the underground, so it's the exact same principle. The heated liquid transfers heat from the house into the ground and returns back up into the house, cooled off. Geothermal systems have some advantages that have raised interest for homeowners around the world. These systems can provide significant savings for heating and cooling. They can work well in almost all climates, they're environmentally friendly, last longer than conventional heating and cooling systems, sometimes dramatically longer, and require low maintenance.
So the takeaway from this is geothermal does not generate electricity at a homestead level. Geothermal electrical power generation is only possible with large power plants using underground heat that's deep in the ground. We know of some places, Iceland and Greenland, and that have geothermal activity, and they're able to not only make electricity but heat homes and things like that. If you live in an area where your property has a hot springs, it would be worth looking into this concept. But in general, geothermal is not available enough to be practical on a home level to generate electricity, while it can be used to supplement and reduce the electrical cost of doing electric furnaces. So therefore, we'll strike geothermal off the list because our goal here is to find alternative energy production methods, and pedal power doesn't make enough, and geothermal doesn't generate electricity at a homestead level. So we'll strike both of those off of our list and move on to microhydro. Now, microhydro is using water's movement, either downhill or moving along like a waterfall, to be able to take that energy and turn it into an electrical producing generator. So here's a reminder of how that works.
Hydroelectric energy is usually the most economical form of renewable energy. If you have a constant flow of water from a stream or river, you can produce electricity in turbines that literally run 24 hours a day. Few other forms of alternative energy can boast such continuous running. However, because hydropower is the most limited in availability, it is usually the least frequent form of electricity production.
So microhydro has some really good advantages. One is it can work day or night. It can work in any weather, and it, in ideal conditions, will produce power 24/7, 365. The problem is your property needs to have enough water flow, gallons per minute, on a creek to have enough volume to accomplish this. Secondly, it needs to generate water pressure, pounds per square inch, and that's done by the vertical drop and that's called head. So if you happen to have property with a creek on it that starts at the top of your property and goes down, you have a gold mine of possibility for being able to make micro hydro power generation. It does require a minimum amount of maintenance because it has moving parts, but in general, very minimal amount. So we're going to leave micro hydro as a viable option, even though we've canceled out geothermal and pedal power. Micro hydro, if you have that possibility, is probably the number one choice. The problem is they're not very common to be available, the criteria that you need to make that a reality. But let's say, for instance, you have property where you have a creek that runs year-round, and you go to the top of the property with a 5-gallon bucket and a stopwatch, and you have a little bit of a waterfall aspect over a rock or something where you can gather the water, and you gather a bucket, a 5-gallon bucket, and dump it, gather another 5-gallon bucket and dump it, and keep doing that until you have done a minute. And that'll tell you how many gallons per minute. So let's say you have 5-gallon buckets in a minute. That's 25 gallons per minute. That's quite a bit of water. So if you have that at the top of your property, and then the vertical drop is 100 feet, such as not the length of the pipe, but the actual vertical drop, then you could say with a 2-inch pipe or bigger, you could easily get 60 pounds per square inch at the bottom of the hill. And that would do a very nice job of generating electricity. If you go to Google Earth on your cell phone and you go to the top of this intake of the water, it will tell you the elevation in approximate terms. Then go down to the bottom where you would have the end of your penstock pipe and go into your generator and look at that elevation and subtract one from the other, and that'll tell you how much head or vertical drop you potentially have to deal with. So micro hydro, if you have that possibility, though rare it is, it would be an ideal thing to look into seriously and develop because it runs all the time and it's virtually maintenance free. Now we're going to look at wind. Wind is another one of those alternative energies that depends on what you have available on your property. A wind generator doesn't begin to produce anything until about 6 miles an hour of wind. 6 miles an hour is a respectable amount of wind. But let's say you have a 300-watt wind generator. That means at full wind calculated speed, let's say they design it for 15 miles an hour wind, so you'd have to have 15-mile-an-hour wind in order to get enough electricity to meet what that wind generator is rated for, say 300 watts. If you're getting 6 miles an hour instead of 15, you might only be making a couple of watts of power. And so it's important when considering wind generator that you analyze how much wind there is throughout the day and throughout the year. And this can be done with a variety of little devices that can measure and log the wind. And before investing a great deal of money in this, it's important to know that you, in fact, have enough wind for an extended period of time to be able to make it work. Now, it doesn't have to be 24/7, but one advantage of wind is it does work in the dark, unlike solar. It works 24/7 if there's enough wind. And so wind is a really nice option if it's a possibility. So let's take a look at how wind works.
Wind generation of electricity through large or small turbines is a fast-growing form of energy production. Though it is easy, clean, and relatively inexpensive to install, available windy areas are not as numerous as are sunny areas. Therefore, it is important to check your exact area for any desired wind turbine. Also, local codes may limit putting towers in your area. Check local area wind maps to see if this is a viable source of power for your area. Many rural sites, free of large obstructions, are great for wind turbines. One 2-kilowatt generator can often supply half of the total electricity for an average home.
Are you ready to rethink your approach to sustainable energy? While solar panels have been the go-to for many homeowners seeking to reduce their carbon footprint, there's a new contender in town that just might outshine them all. Introducing the wind turbine for home use, a revolutionary technology that harnesses the power of the wind to generate clean and renewable energy right in your own backyard. And the best part, it's more efficient and cost-effective than traditional solar panels. So get ready to be blown away by the incredible potential of wind turbines and discover a whole new way to power your home with sustainable energy. Solar panels have been popular among homeowners for years, and for good reason. They're a great way to reduce your carbon footprint and save money on your energy bills. However, they do have their limitations. For one, solar panels are reliant on direct sunlight in order to generate electricity. This means that on cloudy days or during the winter months, their efficiency can be significantly reduced. Additionally, solar panels can be quite expensive to install and maintain, making them a less accessible option for some homeowners. Enter the wind turbine for home use, a technology that's been gaining traction in recent years as a viable alternative to solar panels. By harnessing the power of wind turbines can generate clean and renewable energy even on days when the sun isn't shining. And with advances in technology and manufacturing, wind turbines have become increasingly cost-effective, making them a more accessible option for homeowners looking to make the switch to sustainable energy. But don't just take our word for it. In a study conducted by the Department of Energy's National Renewable Energy Laboratory, researchers found that small wind turbines were able to generate more electricity per square foot than solar panels. And while the initial cost of a wind turbine can be higher than that of solar panels, the overall cost of wind power is actually lower in the long run due to its higher energy production and lower maintenance costs. So if you're in the market for a sustainable energy solution for your home, don't overlook the potential of wind turbines. With their efficiency, cost-effectiveness, and reliability, they're a technology that's worth considering as you seek to reduce your environmental impact and save money on your energy bills. One of the key advantages of wind turbines over solar panels is their efficiency. Wind turbines are able to generate electricity in a wider range of wind conditions than solar panels are able to generate electricity in sunlight conditions. This means that wind turbines can produce energy not only during the day, but also during the night and in adverse weather conditions, such as heavy-duty rain or snow. In addition, wind turbines are able to generate more power per square foot than solar panels due to the fact that wind energy is denser than solar energy. This means that a smaller number of wind turbines can generate the same amount of electricity as a large number of solar panels. Furthermore, wind turbines can generate energy at wind speeds as low as 6 miles per hour, which is much lower than the minimum amount of direct sunlight required by solar panels. Another advantage of wind turbines is their flexibility. Unlike solar panels, which must be installed in a fixed position on a roof or in a yard, wind turbines can be mounted on a pole and rotated to capture the optimal wind direction. This means that wind turbines can be placed in a variety of locations, such as on rooftops or in open fields, making them a more versatile option for homeowners. Overall, wind turbines offer a number of advantages over solar panels, including their efficiency, flexibility, and ability to generate power in a wider range of weather conditions. As a result, wind turbines have become an increasingly popular choice for homeowners looking to reduce their carbon footprint to save money on their energy bills. So if you're in the market for a sustainable energy solution, be sure to explore the potential of wind turbines. Another key advantage of wind turbines is their cost effectiveness. While the upfront cost of a wind turbine may be higher than that of solar panels, the overall cost of wind power is actually lower in the long run due to its higher energy production and lower maintenance costs. One reason for this is that wind turbines have a longer lifespan than solar panels. While solar panels typically last around 25 years, wind turbines can last up to 30 years or more with proper maintenance. This means that homeowners can enjoy the benefits of wind power for a longer period of time without having to replace their energy system as frequently. In addition, wind turbines require less maintenance than solar panels. Solar panels can be susceptible to damage from weather events and debris, which can require costly repairs or replacements. Wind turbines, on the other hand, are built to withstand harsh weather conditions and require less maintenance overall. Finally, wind turbines may offer the potential for cost savings through net metering. Net metering allows homeowners to sell excess energy generated by the wind turbine back to the power grid, earning them credits on their energy bill. This means that homeowners can potentially offset the cost of their wind turbine over time by selling excess energy back to the grid. Overall, wind turbines offer a number of cost advantages over solar panels, including their longer lifespan, lower maintenance costs, and potential for net metering. So if you're looking to reduce your carbon footprint and save money on your energy bills, consider the potential of wind turbines for your home.
Like they're trying to sell wind generators. And you'll notice when we watch the video, it would show household wind generators sitting on a roof. Then they would show some big wind farm with huge blades. And so some of this information I think is deceptive, and we're going to take a look at these different aspects and try to understand more carefully how viable these comments are about the benefits of wind generator. So the first we're going to look at is wind power day or night. Video clip.
Introducing the wind turbine for home use, a revolutionary technology that harnesses the power of the wind to generate clean and renewable energy right in your own backyard. And the best part, it's more efficient and cost-effective than traditional solar panels. Solar panels are reliant on direct sunlight in order to generate electricity. This means that on cloudy days or during the winter months, their efficiency can be significantly reduced.
So wind does work when there's enough wind, and it will work day and night. But solar will work in the daylight only. So it is true that wind, if there's wind consistently at a high enough level all day long, then wind will work day or night. But just like solar has daylight hours and darkness hours, so wind is not necessarily consistent. And sometimes you'll have no wind and sometimes you'll have wind. So a person, once again, needs to really compare. But it is true that wind power will work in the dark and in the daylight. The next item they pointed out was wind is less expensive to maintain.
Solar
Video
panels can
clip.
be quite expensive to install and maintain, making them a less accessible option for some homeowners. While the initial cost of a wind turbine can be higher than that of solar panels, the overall cost of wind power is actually lower in the long run due to its higher energy production and lower maintenance costs. While the upfront cost of a wind turbine may be higher than that of solar panels, the overall cost of wind power is actually lower in the long run due to its higher energy production and lower maintenance costs.
Wind turbines have moving parts, and they are difficult to maintain because they're up on a pole. So I don't understand how they can say wind is less expensive to maintain when solar requires no maintenance whatsoever. So I don't agree with that. It may be in the case of big commercial situations that it might be true, because solar farms, big solar farms, they'll use those solar panels for a number of years and then they'll replace them even though they still work. And that doesn't necessarily make it cost effective, but wind turbines less expensive to maintain? I don't think so at all. So the next item they said is wind produces more energy per square foot.
In a study conducted by the Department of Energy's National Renewable Energy Laboratory, researchers found that small wind turbines were able to generate more electricity per square foot than solar panels.
So this is a true statement. Wind turbines do take less ground space. Therefore, it is true that wind produces more energy per square foot. But if you're not limited by space, then solar is a good option. But it is a true statement to say that a wind generator takes less ground space, therefore produces more generated power per square foot. True statement, but a little bit misleading. The next comment they said is wind turbines can produce energy at night and in adverse conditions.
One of the key advantages of wind turbines over solar panels is their efficiency. Wind turbines are able to generate electricity in a wider range of wind conditions than solar panels are able to generate electricity in sunlight conditions. This means that wind turbines can produce energy not only during the day, but also during the night and in adverse weather conditions, such as heavy-duty rain or snow.
Wind turbines can produce energy at night and in adverse conditions. Wind turbines can be productive in the dark and on cloudy and stormy weather. This is a true statement, assuming there's enough wind. The next point they made is that wind turbines require a minimum of 6 miles per hour.
Wind turbines can generate energy at wind speeds as low as 6 miles per hour, which is much lower than the minimum amount of direct sunlight required by solar panels.
So in order for the wind turbine to reach full power potential, it needs to have significant wind, and 6 miles an hour is just the beginning of making any electricity at all, which is not the rating of the wind generator. They made a statement that 6 miles an hour minimum for wind is better than the minimum required for the sun. Now, I don't know what in the world they're saying because you don't have to have wind to make the sun work. I think they're just making vain comments to try to convince the public. So the next comment they made is wind turbines adjust to the wind direction.
Another advantage of wind turbines is their flexibility. Unlike solar panels, which must be installed in a fixed position on a roof or in a yard, wind turbines can be mounted on a pole and rotated to capture the optimal wind direction. This means that wind turbines can be placed in a variety of locations, such as on rooftops or in open fields, making them a more versatile option for homeowners.
This is true. Wind turbines can adjust the direction where solar panels are fixed in position. The only exception for this is the old-fashioned pole-mounted solar panels that had a motor to adjust in the direction of the sun, but we have found out in a previous presentation that this is not financially practical because it's a moving machine that requires maintenance, and it's easier to just have more solar panels than to try to make your half a dozen panels turn to reach the sun. Now, they also said wind turbines adjust in wind directions. Wind directions typically automatically rotate to face into the wind. The big wind turbines do this by computers and a weather station readout, whereas a homestead wind turbine would do it mechanically because it would have a tail on the back, much like an airplane has a tail in the back, and that wind would push it into the direction of the wind. So pretty simple, and it would work much like a windsock at an airport. And it is true, solar panels are typically mounted in a fixed position. Another comment they made in this video was that wind power is more efficient and cost-effective than solar. I don't find this to be true. It probably is in the case of large industrial size operations, but for a homestead, solar is more cost-effective. The wind power is more efficient in that if you have wind all the time, it will in fact do day and night and in inclement weather. But being cost-effective, I don't think that's the case. I think solar is more cost-effective because it has no moving parts, so there's no maintenance involved. They also said it is less expensive to maintain compared to solar, which again, I don't believe is a true statement because solar doesn't really have any maintenance. They also said while wind turbines are more expensive than solar in the long run, cost is lower due to high energy production and the maintenance expenses. Here again, I don't think this is true because they're talking about part of the maintenance cost is replacing all of the solar arrays, and you don't really have to do that. They'll last 25 or 30 years, 25 years, and even at 25 years, they're still running at 90% capacity. They don't just all of a sudden quit. Wind turbines have a longer lifespan than solar. There again, unless it's a commercial industrial size unit, I don't believe that to be true. I believe it's very much not the case in a homestead size wind turbine compared to solar. They claim that wind turbines require less maintenance than solar panels. Not so, I don't believe at all, because there's no maintenance for solar panels. An advantage of wind turbines over solar is they qualify for net metering. Well, they both qualify for net metering, so that doesn't make it any more advantageous for wind turbines. Matter of fact, net metering can go for any form of electrical generation that you have that you're feeding back to the grid. So, is wind power an option for your property? So, in my opinion, micro hydro and wind are viable options, but they depend on the property that you're talking about using it on. Again, micro hydro needs flowing water, needs it going downhill pretty much, and wind generation, you need wind. And there again, if you have enough wind, it's probably not a very comfortable place to live. So now let's take a look at solar. Solar power is the most popular form of alternative energy, and for good reason. And here's a reminder of how that's done. Video clip.
Solar PV takes small silicone cells mounted in panels and covered with glass and produces electricity for your home or business. This electricity, when inverted, is exactly the same voltage and current as you use every day. When tied to your current electrical panels, it supplements what you use from your commercial electric company. When you are making more than you use, it will send the surplus back to your electrical company and sell the power back to them.
Advantages of solar. So as I see it, there are advantages with solar. It's free power. It has no moving parts, so there's no maintenance. And it's good in any location. Varying degrees of how well it will perform depending on how much the sun is, but it is available at any location as long as it's got sunlight and not in the shade. The disadvantage, of course, is it's not available in the darkness or in very inclement winter weather. So I'm going to show you some examples of solar installations. This is done by Backwoods Solar, which in my opinion is the best source for getting advice on how to do solar and have them design your system. They'll do it for free, even if you don't buy the equipment from them. They've been doing it for 35 years, and this particular video clip is installations they have in British Columbia, Canada. So, to recap, in my opinion, solar is the #1 choice. And depending on what options you have with your property, wind or micro hydro, or maybe both, would be good alternatives. But solar should always be the mainstay, in my opinion. And as we've seen, geothermal is not an option because it actually doesn't generate electricity, and pedal power doesn't generate enough electricity. So let's take a look at what kind of configuration you would do. As we've talked about in earlier presentations, you can do grid tied, where you don't have battery storage, but you are feeding back to the grid or using the grid. It's a two-way meter, net metering. Or hybrid, which is the same thing, except you also have battery storage. The advantage of hybrid is that if the grid goes down during an outage, you still will have power because you have batteries. Otherwise, you also are still able to do the net metering by sending back and forth between the grid. And then, of course, off-grid solar. Some may choose to be off-grid because they just don't want to be connected to the outside world services. They want to be completely independent. Another reason might be that the electrical power isn't close enough to their homestead where it's financially practical to bring it in. So it might be cheaper in that case to invest in off-grid rather than bringing in power from the power company. And then if you're going to be off-grid or hybrid, you're going to have batteries. We talked about this in a previous session. And by comparison, of course, there's lead acid and there's lithium batteries. Lithiums are more expensive, but they are a really good choice because of some factors like you can discharge them deeper than you can with lead acid. And lead acid also, in most cases, requires maintenance about once a month to top off the fluid in the batteries with distilled water. So what I'd like to do is show you something that Backwoods Solar has on their website, that if you're going to consider doing your own solar system, that this will be a very helpful thing. First of all, they have a section called the Backwoods Solar Learning Center. And the area that I want to focus on is at the bottom, off-grid worksheets. So we're going to look at a load sheet, and this is an example of a load sheet filled out. And what it is how much power do each of these kinds of things take in your house? And this is just an example. In order for you to figure out how much power you need and be able to fill out this form, you need to use this kilowatt meter. It's an inexpensive device that will give you the tools you need to be able to understand how much power you need to generate and how big a system you need. Video clip.
The kilowatt meter is a simple household energy reader used to measure how much electricity is consumed by your appliances and electronic gadgets, even when they're turned off. First, choose an appliance whose electricity usage you want to measure. Next, plug the kilowatt meter into an outlet and plug the appliance into the kilowatt meter. To calculate energy used while the appliance operates, turn on the appliance. If you wish to determine if the appliance has a phantom load, or the power used while switched off, do not switch on the appliance. Now press and hold the reset button for about 5 seconds. Do this prior to measuring each appliance or device. Do not skip this step. Finally, press the Set button again. Save will appear briefly in the display. Now leave the appliance plugged into the kilowatt meter. You can usually get an accurate reading from small appliances and electronic devices in 24 hours. Large appliances, such as refrigerators or window air conditioners, may need to be measured for a week or more. This is due to the variables that affect appliance efficiency, such as weather, room temperature, or, for a refrigerator, the amount of food inside. Monitoring how much your electronics and appliances cost to operate will help you become more aware of your energy consumption.
So with the use of the kilowatt meter, then you can go and analyze each appliance in your house, whether it's a TV or refrigerator, etc. And one at a time, you take the kilowatt meter, plug it in the wall, plug the device into it, mark the time of day when you put it in, and wait at least 24 hours, and then do the math, filling out the sheet here for that line item, and it will then translate the information from the kilowatt meter based on how many hours in the day that you did it and how many watts it was, and it will give you watt hours per day. And this is important because some devices like a refrigerator don't run all the time. They'll run, and then when it gets to where it's supposed to be for temperature, it'll shut off, and back and forth. Same with the water pump. The water pump will pull a lot of power from your well, but it doesn't run unless you're running water. So that's why running at 24 hours with the kilowatt meter is important. So now let's wrap this up by talking about tax credits. Now this example is in the United States. Any United States state has this because it has to do with federal income tax. If you live in another country, I would suggest you explore what options there might be where you live. In developed countries, it's very likely you would have something of this type. But we will use this example of the United States system. Basically, a tax credit is different than a tax deduction. Let's say at the end of the year you owe $5,000 tax. And so if you have a tax deduction, say a contribution towards a church or a charity, then that is a deduction, whereas this is a tax credit. The difference is that the tax deduction takes the amount that you contributed for that charity, and then it has a reduced rate of taxes, whereas this is straight off the taxes. So that's how a federal tax credit works. And are you eligible? You are, as long as you pay taxes. If you're on a fixed Social Security income, or you're elderly, or you don't have a job where you're having income that affects your income tax, then it wouldn't help you because you have to have a IRS federal tax that you pay in order to deduct off of that tax. So most people qualify for this if you're a working person, but there are some exceptions that might be on a government assistant fixed income and you don't pay any income tax. So therefore, this wouldn't work for you. So what expenses are included? Actually, anything that has to do with you designing, building, constructing a alternative energy system. Again, solar is the most common, but it could be hydro, it could be wind, and everything involved is a credit. I'm using the word deduction, but any of these expenses qualify as long as you have a receipt for having paid it. So that could be hiring someone to do the whole system, turnkey. It could be if you're building it yourself, all the materials. Obviously, your labor doesn't count, but you might hire someone to help you, and that could be a deduction if you have a receipt that you paid it. So that anything that has to do with building this system is batteries, charge controllers, inverters, wire, conduit, cement, building a rack, buying a rack, cement truck. All those things are a qualified expense for a tax credit. So when we take a look at these different avenues that we have looked at for developing your own power generating on your property, my suggestion is number one is solar. Make sure your property faces towards the sun and not in the shadow all the time. Like in the northern hemisphere, you'd want to have southern exposure more or less. But if you were on the north side of a mountain and it never had direct sunlight, you're going to not capitalize very well on having solar. I would recommend doing solar, and then if your property affords the option, supplement your solar with either microhydro or wind, depending on the resources that are available on that particular property. In most cases, wind won't be an option because there isn't enough wind or legal restrictions of where you live. Same thing with the hydro. You may not have the required flow of water to make it work, or you might be legally bound to not be able to do it. But there is no restriction on solar. And so for sure, I recommend solar. And one last thing about solar is if you live in an area where you have a dark, rainy winter or snowy winter, just accommodate more solar panels to make up for the difference. Solar panels are cheap enough that you could overbuild it so that when you are in those dark and gloomy times, you still have the best possibility of having that power. So that's the final recommendation I have regarding alternative energy choices. To be aware of new videos like this one, be sure to subscribe to the Preparing for the Time of Trouble channel. For more free videos and downloadable audio podcasts, as well as handouts, go to www.preparingforthetimeoftrouble.com. Topic categories include recordings of live seminar presentations, country living, sustainable gardening, homestead remedies, how to be self-sufficient when the grid goes down, wild edible and medicinal plants, hydrotherapy, and end-time Bible prophecies. To take advantage of these free resources, go to preparingforthetimeoftrouble.com.